For the top e-commerce brands in China, 80% of the image, videos, and posts are generated not from any human, but AI behind the scenes. From photo shooting, editing, graphic design, layout, and day-to-day operations. Some of those e-commerce brands were able to cutting down 40 people assets generation and operation team. And what is even crazier is that those software companies who build those automations for e-commerce companies were able to set up their own AI streamer and influencers with just 2% and generate more than 4 million USD monthly sales. So I truly believe there are a huge amount of opportunities around AI in e-commerce to be unlocked at the global scale. If you remember, a few months ago, I was trying to build a virtual try-on AI pipeline, which is fairly complicated. But Meta just released a model called Lift that is specifically focused on the virtual try-on use case. With this model, you can spin up an AI image generation pipeline in just 10 minutes. And not only for virtual try-on, there are even models for virtual off, where you can provide an image of people wearing certain clothes, and it will automatically strip out the clothes itself for producing high-quality product shot. All those different models are for you to stitch together and build automation pipeline if you know the use case. That's why I want to show you how can you take these models and build different type of image generation pipeline for real-world e-commerce use case. And I will take you through step-by-step the basics so that you can learn and adopt for your own use case. Without further ado, let's get started. One of the most powerful tools that we're going to use is ComfyUI. It allows you to download and upload different AI models you saw that are interesting and stitch together different workflow. And it's purely open source, so you can download and run on your local machine if you want. But you can also build and run pipeline on cloud-based platform like Running Hub, RunComfy, and a bunch of others. They basically allow you to build ComfyUI workflow, their hardware, which normally can be more powerful than your home PC. And my best practice is normally use Running Hub to build out and iterate the flow, and then use RunComfy to host the ComfyUI pipeline. And firstly, I want to cover some basics. How do you use ComfyUI to do text to image, image to image, mask, and Controlnet, so that you know the principle about how things work? And then I will take you through a case study of how to use interesting model like Laffa, as well as build some more complicated workflow for AI model swap, which is actually a very popular use case. Because for some Asian companies who are going international, you normally need to get a foreign model in the local market to do product shots, which costs a lot of money. But this pipeline can enable any company to just take a photo themselves and swap the model and background to something that fits the local market. But before I dive into this, for those e-commerce business, usually an online purchase begins with a search. As AI search engine like Perplexity continues to roll out, publishers estimate that they can lose 20 to 40% of their organic traffic. So how can you rethink your SEO strategy in this AI search engine era? Is critical. That's why I want to introduce you to this AI SEO masterclass that's trying to tackle this problem, and it is completely free. It covers loads of topics and tools in terms of how to get started and advance for AI-driven SEO and supercharge your online visibility. It gives you tools to grow your brand, and you can see the full report, including how your brand is being discussed by the AI engines, as well as how your brand presence measure up in your industry and competitors, with detailed analysis and actionable insights, as well as AI research tool for you to understand which competitors are ranking at similar keywords that you are paying for, and also give you a breakdown of what type of keywords they are betting and what's their cost, and tips and best practice from the interview with marketers from top firms. So I definitely recommend you to go check this out if you want to learn more about how to do AI-driven SEO. I have put the link in the description below for you to download. Now let's get started with ComfyUI. Let's firstly cover a few basics of how to use ComfyUI. The most simple one will be building a text-to-image pipeline. So you can double-click and then search for KExampler. So KExampler is a specific node that to generate image in ComfyUI. And in the world of AI image generation, exemplar means a method or algorithm that will be used to guide the AI in turning random noise into meaningful image. If you're not familiar with how does the AI image generation works, basically the starting point would be a super noisy image like this. And the AI model is trained to reduce noise a little bit every time and repeat this process multiple times to eventually get a high resolution image generated from this noise image. So back to ComfyUI. We'll firstly load a model. So I will search for load checkpoint. And checkpoint is the AI image generation model. And if you're using cloud-based ComfyUI platform, there are probably a bunch of models loaded already. The common one I will be using is like a Dream Shaper XL, and I'll click use. And then we also need to connect positive and negative prompt. You can drag it out and then select the clip. So clip is basically a model that vectorizing both image and text in the same vector space so that we can group text and image with similar semantic meanings together. For the AI model to understand what does a cute cat means, it will need to understand for each image what the different factors and keywords are, and then plot all the image data on those text descriptions to better understand when we give a word, what are the most relevant images of this word look like. Each image has hundreds of thousands of different text description data converted into vectors, and this is exactly what this clip do. So this model has been trained with huge amount of text and image data so that it can guide the model to generate image based on text prompt. So here we can say a cute girl, raw photo, high resolution, and negative prompt to be happy. But we also need to connect the clip model to those prompts so that we can vectorize those texts. And in the end, we also need to a latent image. As we mentioned before, those text to image model basically will start from a very noisy image to gradually reduce noise in high resolution like this. This empty latent image is basically the starting point super noisy image. And denoise means it will remove noise 100%. And step means how many steps it will take to reduce noise. And then we'll generate latent. So we need to also use VAE decode to turn the data into proper image. And we will connect the VAE from the itself. And from the image, we will save the image. So that's pretty much it. A very basic text to image pipeline. If you click around, okay, so you can see an image has been generated here. And you can increase steps here to get better result as well, but it will also take longer to generate. And I will create a group called text to image. So this is the most basic pipeline. But next, we can also do image generation. And what I will do is that I will copy the workflow above by doing Control and select everything and Shift drag it here. And the way image to image generation works is basically instead of passing on empty, and the way image to image generation works is basically instead of passing on the empty latent image, we're passing on existing image to the K-sampler. So you can still keep some essence of the original image, but do some additional generations. So the way it works is that I remove this empty latent image and add a called load image. We can pass on the image that we just generated earlier. And we also need to turn it from pixels into latent image. And we also need to change denoise to, instead of regenerate from scratch 100%, we change it to be like 50%. And I can change the prompt here a little bit. So I can say a cute, happy girl, and there's no negative prompt. And we also need to connect the same VAE to the VAE encode. And let's try it. So now you can see that it kept some essence of the other image and changed the face from a sad girl to a happy girl. This is how you can build an image-to-image generation pipeline in ComfyUI. And next, another very important concept is mask. So mask allow you to communicate with AI model which specific part that it should make updates versus part that it shouldn't. And I will just quickly copy the pipeline we generate above, pasting here. And this time, let's say we want to update this image, and I want to change just the shoes. What we can do is that I can add a new node called load image as masks, and I will upload same image to this node. And I'm going to right click. There is one option called open in mask editor. This is where it will allow me to build some masks. So I'm going to mask over the shoes and save to node. Then I'm going to add a new node called set latent noise mask. And then instead of passing on the original image to the latent image, add that to the latent noise mask, and then add this new latent to the K-sampler. And the prompt here, I can change to a woman wearing high heels and run. So now in this generated image, you can see the rest of the image didn't really change. However, the shoe has been changed from a sneaker to the high heel. This is how this mask is became really useful because they allow you to make updates to very specific part that you're not happy with. But if you're trying to build an application, most likely you won't be drawing the mask yourself. So quite commonly, we will be using some other AI model that can automatically detect certain items using text prompt to do the masks. For example, I will search for clip segment. So clip segment is a node that can take an image, and we can use text prompt like shoes. This will automatically detect and create the mask. And the first preview this mask is generated, and then I will connect the mask here. And let's try this workflow. But before I do that, I select all the other previous nodes and do Command B. This allows us to skip those nodes so we don't waste the computer resource. And cool, you can see the clip segment automatically identify this area is where the shoes are. And there are a lot of AI models you can use to automatically segment the image. And the last part I want to cover is Controlnet. You probably heard about Controlnet, but not sure what that means. So Controlnet is a specific type of model that has been used in image-to-image generation, where it allows you to extract specific type of essence of the original image and use that to generate new images. And there are different type of control net you can use. For example, this is called canny edge, and this is a human pose where it can extract the pose from image and generate new ones, as well as semantic segmentation, where it can extract certain segmentations, gaps image, as well as depths. So as an example, let's say we want to take this image to extract the human pose here and then generate a new image. So I'll load this image first. Then I'll add a new node called Controlnet preprocessor. And here I will search for open pose. And here you can see there are a bunch of different preprocessors. The one we're going to use is open pose. And I'm going to just preview this image and you can quickly run this. So it is able to extract the pose information from the original image successfully. But at the moment, this pose is just an image. To actually pass on this to AI model, we will need to mix this information as part of prompt. So I will again quickly add a k-sampler. The model we will be using is the same one that we have been using so far. And here, let's say we change the original prompt to an angry businessman. Connect clips. But as we mentioned before, the way we pass on this information to the k-sampler is through the prompt. So we will actually add a new node called apply Controlnet. And I will need to add the positive prompt as well as the negative prompt here. And the image we added here will be the image for Controlnet. And the VAE can be the same VAE we use for the image generation model. And we also need to load Controlnet. And here I will use this Flux Union Pro Shaker. And the strength I change to 0.8. So strength basically means how rigid it will follow this image. And then we're going to pass on this positive prompt and negative prompt to the k-sampler. And the latent image, we can use empty latent image here. The only part is that I want to making sure the image size of this latent image to be the same as the image we uploaded. So I will also add a node called image size information. And this will extract size information so that I can pass on to this empty latent image. And when you can see this width and height only allow users to change by typing here. And what you can do is you can right click and convert width to input. So we'll change width to input and we'll also change to input. Then we can start connecting those things together. So that's pretty much it. I can now add to VAE decode. The VAE will need to be the same as here and then save image. So I can try to run this. Okay, so I got an error here. I think the problem is that I probably choose the wrong Controlnet model. I should be probably using this one from the Stable Diffusion Excel. And let me run again. Okay, now you can see that these two images are having very similar pose if I compare them side by side. So this is how you can use Controlnet. And you can imagine this is very useful for our e-commerce specific use case where you want to keep how the model looked like before. So this covers basically the core concepts in ComfyUI for you to build complex workflows. Now let's get through a real world use case of how to build this type of AI model swap pipeline. But meanwhile, if you want to get a link to this tutorial workflows that we just went through, you can join the AI Builder Club community that I'm building, where I have all the links to different ComfyUI workflow that we just went through. And you can just clone and use. And I also share industry expert tips as well as practical projects that you can take through to learn how to build AI apps at a weekly basis. But more importantly, there is a community of top AI builders who might already experience the problem and challenge you're having today. So you can just come and post your questions. Me and other community members will just come and help. I have put the link in the description for you to join if you're interested. And now since we've learned the basics of how to use ComfyUI, let's do a real world practice. One of the key use cases when I talk to friends who are doing e-commerce China but are going international is that they want to have product shots in not Chinese but local people like either Western, Africa, or Southeast people. And if you hire a real person to do this product shot, it's going to cost a lot of money. So we'll build an AI model that can take the original image and transform people into different nationalities. So it can be useful for those e-commerce that are trying to selling products in specific local markets. So let's load the image. I'll drag this image in. First step we're going to do is that we want to create a mask about which part we want to keep the same as the main product to showcase. In this case, could be the clothes itself, so that we can pass this mask information to just change everything else but the clothes itself, to make sure the general image doesn't change any details of the product. And to do that, we're going to use Meta Segment Anything model. It is a really powerful model that can provide super accurate image segmentations. So I'm going to search for SAM Loader impact. So impact is like the simplified version versus pipe has a lot more advanced settings. And we're going to choose this model, and we're going to prefer GPU because we're running this cloud environment. And we're also going to use a grounding dyno. So what does grounding dyno allow you to do is to pass on a text prompt about a specific thing that you want to segment, and it will be able to segment just that specific item. And I normally change this threshold to 0.4, and I will also add a image resize. So this node will allow us to turn any image users uploaded into similar resolutions. So it will be easier for us to manipulate the size of the original image, Controlnet image, all to be the same. And the method gonna keep proportion, and that's pretty much it. So I will connect SAM model here, grounding dyno model here, and the resize image here. And for the mask generator, we can do layer mask preview. This node will allow you to take a look of the mask generated to see if it's correct or not. So that's pretty much it for the mask. So you can see that this provides really specific and accurate. It also cut hair off as well. And on the other hand, if you're trying to generate image for like cosmetic products, you can upload this new image and then change the prompt here to be product bottle. So in this case, you can see this part of product is segmented. So this is the first step of mask. And next, we're going to use this masked image to an image generation model to manipulate the face of the person. And to do that, one problem you might have is that it might be difficult for you to generate a really good prompt to describe the type of person you want to generate. Like for a Chinese person versus Vietnamese, you probably need to add a lot more detailed prompt to guide the model. And there's one node that's quite useful called Portrait Master. So this is pretty much like a prompt generator. You can choose which type of picture it is, the gender, the age, body type weight, and facial expression, face shape weight, hairstyle, and a bunch of stuff. So you can play with those all different settings a little bit. It will help you generate a positive and negative prompt. So you can add a node here to show the text. And for now, I'm just going to disable those ones, and we can run this. Pretty much just generate a really nice prompt based on the settings you have here. And if there are additional prompt you want to pass on, you can also just put in the prompt here. And now since we have the prompt ready, we want to load the model and use Controlnet to capture more detail from image and generate new image with this updated prompt for the type of nationality people we want to add to. So I'm going to unselect those ones. We're going to load the model, and here I will be using a node called Efficient Loader. So Efficient Loader is a special type of checkpoint loader that has a bunch of features packaged together. So here I will choose a model, and we'll use Dream Shaper XL Lightning model first. And this loader has a positive and a negative prompt, and we're going to convert those to be inputs so that we can pass on from the prompt generated by Portrait Master. And for the token normalization here, we're going to choose lens plus mins. So token normalization affects how the words in your prompt are balanced. The lens plus mins option combines two methods. One is lens, which adjusts the token weights based on the length of words, and min balances the overall strength of all tokens. So this combination kind of helps ensure the longer words don't overpower shorter ones, and that the entire prompt has a balanced influence on the general image. And for the weight interpretation, I'm going to choose A111. But instead of using this model directly, I'm also going to use FreeU v2. So FreeU you can consider as a type of technology that improves the output quality of your model. It normally makes the image sharper with more details. You can read the paper here to get more details. But the purpose of this one basically is increasing the quality of the image outputs. And next, we want to adopt a few Controlnet to capture the essence of the image so that the posture and layout of image will be still kept the same, but we'll just change the detail of the person. And if you remember to use Controlnet, we will do apply Controlnet. Firstly, let's add a depth. So I will connect the prompt here and load Controlnet model. So here I will use LoRa depths, and we will use 256, which is bigger but more higher quality model. And we'll be using Midas depth map, which is quite a popular model for computing relative depths from a single image. And the resolution here should be 1024. And the image here, we want to output the resize image. And just to make the UI more clean, you can add a reroute. And here we can preview the generated depth image to making sure it looks correct to you. And the strength here, we want to change to 0.6-ish because we're actually going to connect two Controlnet together. And this is quite a common techniques. Because if you just do one Controlnet, sometimes it didn't capture the full details. But to enhance that, you can actually add another Controlnet. And by passing on previous Controlnet's prompt to the next one. And for this Controlnet, we can add a line art. So I will add realistic line art. The resolution will be 1024. And again, we were passing on the original image. And we can preview. And the Controlnet model, here we want to use a LoRa Canny 256. And connect image here. And again, the strengths need to be a bit lower because we're connecting multiple Controlnet together. And we can try this again. So you can see that we now capture both the depths as well as line arts, which should capture a lot of details about this image. And now finally, let's generate the first draft of the email. I will search for KExampler, but this time we can also use KExampler efficient. So KExampler efficient is a type of node that has been optimized for speed and resource consumptions. So I'll pass on the prompt here, and model will be the model we load here. And we'll connect the VAE. And for the latent image, we want to pass on the masked image. So I will add a VAE encode to encode the image, and also set latent noise mask. But one thing I will change a little bit is that for the mask, we actually want to invert it because everything else can be changed, but not the product we want to showcase. So I'm also going to add a new one called invert mask and connect mask here. And we're also going to change the KExampler a little bit. So steps for this one, you can actually keep it lower. 5 might be enough because this is just first draft, but we can also just keep it like 10 or 20. CFG basically means this value that controls how restrict AI should follow the text prompt. The lower, it will be more creative, while higher, it means it will be very prompt accurate. In this case, we want to keep somewhere 2 to 3 to keep it more creative so that it can fit into the original image better. For example, we want to change to DPMPP-STE. This is the type of example that generally produce higher quality results with more details, specific at handling some complex details and textures. For scheduler, we want to change to Keras, which again normally leads to higher quality. In the end, let's preview this image. Oh, sorry, I forgot to connect the VAE. This one needs to be connected here as well. Great, so you can see the first version of the image is generated. It captured pretty much the essence of the clothes itself and changed the person to a different nationality. But if you look into details of this image, it is not that great. And this is where we're going to connect this to Flux model, which is really good for generating high quality, high details images. And to just test this, we can change the facial expression here to be happy. And we can run this again now. Now you can see the facial expression here now became smiling. And next, we want to pass on this initial image to Flux model and get Flux to generate more detailed version of this image. So I'll do low diffusion model, and we will do Flux 1 def FP8, and we'll change the weight type to be E4M34N. And then I'll do the clip loader. So this allows us to define different type of clip models for better result. And we're also gonna load a LoRa. And here we will use the LoRa model, which is specifically designed for generate portrait image with a lot of details of human face. Model sampling flux to control the image generation dimensions and sampling behavior. And in the end, I'm going to load the VAE, which should be the ASFT. So I'm going to connect them together, and then we will use anything everywhere 3. So this will help you keep your workflow clean and nice, and reuse some of the models across multiple different nodes. For example, I can connect this to the first one, and then the clip second one, and this VAE to the third one. Now I add a clip model, but it will automatically light up here, which means it will take the clips that has been passed on here. And you can also do the right click show UE links. You can see this has been passing on to this clip model. So this is how this anything everywhere works. Then I'm going to add the sampler, but instead of adding the default KExampler, I'm going to use a sampler custom advanced. So this is special type of sampler that give you a lot more control and also have a bunch of optimization built in. So we will add random noise and basic guider. So guider is like a prompt that we're going to pass on to the model. So I will add a text prompt we have here to the condition. And we can also select the KExampler select to choose the sampler model as well as basic scheduler. And scheduler will be simple 20 steps, and denoise, because we are doing image to image, it will be 0.3. I'll connect sampler here, sigmas here, And the latent image will be the image that we generated previously. And I will drag this latent to here. So let's see the result. For the output, I will do decode and preview image. And for the latent image, because previously the model is different, so we actually want to drag the image here, do the encode with this new VAE that we defined here for the flux model, and then pass on the latent image. Now let's try this. Cool. So you can see this new generated image, the quality looks a lot better than the previous one. A lot of facial issue we had before, now it's gone. But this is not end of this workflow yet, because if you look very detailed, you will see that some of the detail of this close is distorted. And if you are actually doing for proper commercial usage, you don't want this to be happening. So we just are going to add the last step, which is overlaying the product image on top of this. So I'm going to add resize image again to resize this image that we generated with the image size that we got before. And again, I'm going to add a reroute, get image size, key proportion should be true, and we're going to grow mask as well as mask blur. Let's add an image overlay node, passing on the newly generated image as the overlay image and the original image to be the base image, as well as the mask. And the weights, I'll just change to 1024. And in the end, I'm going to save the image. So let's try this. Cool. So this newly generated image, you can see all the details has been kept 100%. We can actually add a node to compare. I will search for image compare this final image as well as original image. So you can see this original image and this is a new image. You can see the detail of the close is 100% the same, but everything else has been updated. And we can try a few different examples like this one. And for this one, we can change the prompt here, maybe the body type a little bit overweight, and let's run again. Cool. So you can see that this also works. And this works with product shot as well. So I can upload this, and all you need to do is just change the portrait master here to shot. You can change it to head and shoulder portrait, and this will give you the image like this. You can say the product detail has been kept 100%. There's something wrong about hand, but you can actually just add another model later to fix the hand distortion. And more examples here. And you can change different type of nationalities. Here's another example. If you're a Chinese e-commerce where you want to sell traditional Chinese clothes to international customers. So this is how you can use ComfyUI to spin up a few critical e-commerce use cases. And there are a huge amount of opportunity and use case for you to build your own. If you want to get ready to use workflow that you can just copy paste, you can join the AI Builder Club community I'm building. We have a link for you to just copy the workflow that we went through today, as well as more advanced tutorial and how do you deploy those workflows. And I share different insights from industry experts, as well as a case study project that you can take and practice of how to build AI apps. But more importantly, there's a community of top AI builders who might already experience the problem that you are having today. So you can just come here, share your challenge and ideas. Me and other community members can just come and help. I'll put the link in the description below for you to join. Hope you enjoyed this. Thank you, and I'll see you next time.